In this video, we're going to look at a few examples of improper integrals with discontinuous integrand. The question here is to evaluate integral from 0 to 1 log x dx. Why is this an improper integral? We know that y equals log x has an infinite discontinuity at x equals 0, or a vertical asymptote at x equals 0. Because the limit as x approaches 0 from plus side of log x is minus infinity. That means as x approaches 0 from the plus direction, the y value goes down to minus infinity. For this reason, this is an improper integral. So what we have is integral from 0 to 1 log x dx is equal to limit t approaches 0 from plus side, integral from t to 1 log x dx. Let's talk about this notation. The discontinuity is at x equals 0. Replace x equals 0 by another variable. In this case, we just use t. Then take the limit as t approaches 0 from the plus side. How do we go about integrating log x with respect to x? Well, we're going to integrate by parts. So let's write that down, by parts. And the formula for integration by parts is integral u dv is equal to uv minus integral v du. And if it's a definite integral, we have a to b, the limits of integration. This part, uv, is already integrated, so that's going to be evaluated from a to b minus integral from a to b v du. We're going to let u be equal to log x. That's the only term that we have. This part is u. This part is going to be dv. So dv is going to be equal to dx. Integrate both sides and we get v is equal to x. That's the antiderivative of 1 with respect to x. And let's differentiate this. We get du is equal to 1 over x dx. Alright, so we've now set up the integration by parts. Let's go through the process. So we have u is equal to log x. Then differentiate both sides. We get du is equal to 1 over x dx. dv is equal to dx. And integrate both sides. And we get v is equal to x. So integral from t to 1 log x dx is equal to u times v. That's going to be x log x. Evaluated from t to 1 minus integral v, which is x, times du, which is 1 over x, dx. Evaluated from t, I should say integrated from t to 1. If we simplify this, we're going to get x log x minus, this x cancels with this x, we get integral of 1 dx, which is just x, minus x, and then it's evaluated from t to 1. It's more efficient to write it all on one line and evaluate it from between those limits. So putting the upper limit in, we're going to get 1 log 1 minus 1 minus, we're applying the fundamental theorem of calculus. Now putting the lower limit in, we get t log t minus t. If we simplify this, log 1 is 0, we'll get 0 minus 1, so we get minus 1 minus t log t, and this minus gets multiplied by this minus, we get plus t. So what we have shown is that the integral from 0 to 1 log x dx is equal to limit as t approaches 0 from plus side minus t log t plus t minus 1. Now, how do we evaluate this limit? Well, this one is easy. That's going to go to 0. And this is just negative 1. But this is the hard part. So let's do that. We have limit as t approaches 0 from plus side of minus t log t. If we examine the pattern, we're going to get 0 times minus infinity. This is known as an indeterminate form. Indeterminate form. And as you have taken a Calculus 1 course with indeterminate forms, we have to apply L'Hopital's rule. So that's what we're going to do. We're going to apply L'Hopital's rule. All right, so we have limit t approaches 0 from plus side. Let's keep log t on top, minus log t, and we'll write t as 1 over t. Now the pattern has changed because this is now going to be minus infinity if you plug 0 for t. 1 over 0 is infinity, so we have infinity over infinity pattern. We can apply L'Hopital's rule. All right, so now apply L'Hopital's rule, differentiate the numerator. We're going to get negative 1 over t. That's derivative of log t. And derivative of 1 over t is going to be negative 1 divided by t squared. If you simplify this, you're going to get just t. And let's put the limit as t approaches 0 from plus side, limit as t approaches 0 from plus side. This is going to be equal to 0. So what we have shown is that the integral from 0 to 1 log x dx is equal to limit t approaches 0 from plus side minus t log t plus t minus 1. And we showed by using L'Hopital's rule that this part is 0 plus, well, limit of t as t approaches 0 is just going to be 0. That's easy. And limit of minus 1 as t approaches 0 from plus side is just minus 1. The answer is minus 1. All right, so now let's look at, so that means, of course, this integral converges and has a value of minus 1. So you can say that this area, basically this area is 1. The definite integral is minus 1, but the area is 1. So 0 to 1, log x dx is equal to minus 1. All right, let's look at another example. Here we have integral from 0 to 2, 1 over root 4 minus x squared dx. The question is, why is this an improper integral? The reason is because the integrand, this is the integrand, 1 over root 4 minus x squared. This integrand blows up to infinity as x approaches 2 from the negative direction. So you can see as x approaches 2 from the minus side, the y value approaches infinity. And for that reason, this is an improper integral. In general, we apply improper integrals when either x goes to plus or minus infinity, so either x blows up to infinity or minus infinity, or when we have a discontinuity in y, when y goes to plus or minus infinity. Since y is equal to 1 over root 4 minus x squared goes to infinity as x approaches 2 from the negative direction, this is a type 2 improper integral known as a discontinuous integrand. So we will write this as limit as t approaches 2 from the minus side, integral from 0 to t, 1 over root of 4 minus x squared dx. All right, so we have integral from 0 to 2, 1 over root 4 minus x squared dx. This is equal to limit t approaches 2 from minus side, integral from 0 to t, 1 over root of 4 minus x squared dx. Now I want to emphasize this. The discontinuity is at x equals 2 because the integrand blows up to infinity at x equals 2. So we replace 2 by a variable. In this case, we use t, then take the limit as t approaches 2 from the minus side. Now this integral has the same pattern as integral 1 over root a squared minus t squared dt. And if you look at a table of integrals, or if you apply U substitution with some algebra, this will be equal to sine minus 1 of t over a plus some constant c. So the integral from 0 to 2, 1 over root 4 minus t squared dt is equal to integral from 0 to 2, 1 over root of 2 squared minus t squared dt. And if we now apply the formula with a is equal to 2, we're going to get, what do we get? Well, what we get is limit as t approaches 2 from minus side of integral from 0 to t, 1 over root 2 squared minus t squared dt. This will be equal to limit as t approaches 2 from minus side, Let me just make some corrections here. I really should be using x here, x squared, and I should be putting x squared here. Dx should be using x squared. Dx, everything has to be consistent here. And t approaches 2, there is our t. That's the limit t approaches 2 from the minus side, sine minus 1 of x over 2. Evaluated from 0 to t. So that's going to give us limit t approaches 2 from minus side. I'm going to rewrite this, sine minus 1 of x over 2 from 0 to t. Evaluated from 0 to t. Applying fundamental theorem of calculus, we get limit t approaches 2 from minus side, sine minus 1 of t over 2 minus sine minus 1 of 0. Alright, so what we have is integral from 0 to 2, 1 over root 4 minus x squared dx. This is equal to limit t approaches 2 from minus side, sine minus 1 of t over 2 minus sine minus 1 of 0. So that's going to give us sine minus 1 of 2 over 2, just plugging 2 in, minus sine minus 1 of 0. And this is equal to sine minus 1 of 1 minus sine minus 1 of 0. These are, of course, inverse trig functions. So let's evaluate these. What is sine minus 1 of 1? This is saying find the angle whose sine is 1. Well, that's clearly pi over 2. Now, of course, the reason is because sine of pi over 2 is equal to 1. What is sine minus 1 of 0? Sine minus 1 of 0 is 0. That's because sine of 0 is equal to 0. So the integral from 0 to 2, 1 over root 4 minus x squared dx is equal to sine minus 1 of 1 minus sine minus 1 of 0. Let me write that better. Sine minus 1 of 1 minus sine minus 1 of 0. And we found this to be pi over 2. Sine minus 1 of 0 is just 0. The answer is pi over 2. That means this integral from 0 to 2, 1 over root of 4 minus x squared dx, this integral converges and has a value of pi over 2. Converges. What does that mean in terms of the shaded area? Let's take a look at that. That means that this shaded area, is equal to 2. I'm sorry, that shaded area is pi over 2. We need to be precise here, so let's fix that. That's pi over 2. And the integral, of course, converges. All right, thanks. I need to make a correction to this page. As you can see, this integral should be with respect to x. So let's fix that. That's dx. The only place that t appears is here in the upper limit. That's where we have our discontinuity. All right, thank you.